Void safety. As we saw in part 1 of this series, this is the mechanism that rids us forever of the risk of null pointer dereferencing. In this part 2, we are going to concentrate on an important Eiffel mechanism towards this goal, which is the object test. I'm assuming that you have watched part 1, otherwise this part 2 would not make much sense, and this is the link to part 1. So remember what we had as an example. We had this little program with a variable p of type person. Normally we should create that person object, but we don't, and so it's not going to work because we try to print the age of that object, but there's no such object. So if we try to compile, is it going to compile? No, it's not going to compile because Eiffel is void safe, meaning that the compiler rejects this code and it tells us with this error message that the variable p is not properly set. What does it mean? Well, it means that the compiler cannot guarantee that p will be attached to an object when we try to use it. Indeed, it will not be attached to an object. So in this segment, we are going to see how to get rid of this error. And the first step is to notice that when we have a variable of such a type, person, what we actually mean in void safe Eiffel is that p at runtime will always denote an object. It will never be void. So if the compiler accepts this code, then it guarantees that whenever you use p at runtime, whenever the execution uses p, then p will indeed be attached to an object of type person with fields such as age. This is the guarantee, this is the fundamental guarantee of void safety in Eiffel. Now, of course, sometimes you want a variable which denotes a reference that could be void at runtime. In that case, the proper declaration is detachable person. This is our new keyword for the void safety mechanism. Detachable means that p could be void. Now, of course, most of the time you don't want p to be void. It's still going to be attached because if it were always void, it would not be very useful. But by declaring it as detachable, you make it possible that p, for example, at initialization time, might be void. So let's do this here. Let's declare p as being of type detachable person. Let me use the opportunity to get rid of the code that is not useful for our purposes that was added by the Eiffel Studio wizard. And is this going to compile? Well, no, of course not. It still has this problem that p.age might not work. Now, there's a way around this kind of problem which is about the same as a general way to get rid of traffic accidents, which unfortunately is not very useful in practice. You know, if we wanted to get rid of traffic accidents completely, then we could put on every road, every 10 meters, a barrier so that cars can only go through if there is no traffic, or maybe the barrier is always closed. So certainly there would not be any car accidents anymore, but this is not a very useful way to organize traffic. Here we could do something a bit similar by having an object test which only has a then clause. Let me explain. We could say if attached p as x, then print the age of x. What does this mean? Well, yeah, in this case we can still say p, but we should actually say x. So we are testing whether p is attached. This is our first example of the object test, and I'm going to give the details in a second. What it means is if p is not void, then we call it x and we print the age of x. Is this going to compile? Well, yes, it's going to compile, because now we have made sure that if we print the age, p is attached. Is it going to run? Well, yes, it's going to run. On the other hand, it's completely uninteresting. It doesn't do anything, right? Because there's no else clause. There's only a then clause. And since the property is never true, it's never going to do anything. So it's a little bit like this approach to traffic safety, which essentially prevents cars from moving along. We are going to have to find a better solution, but still, let's start with the object test. The object test is a quite general construct, and here it has the general form as shown, attached tx as x, where t is a type, exp is an arbitrary expression, and x is a name which is not used in the enclosing context, so it's a new name that will be used to refer to the value of x locally. This is a quite general mechanism, and it provides us with the following semantics. It's a Boolean expression, right? So it has a value true or false, and the value is true if and only if the value of exp, when this expression is evaluated, the value of the expression is attached to an object whose type is t, or a conforming type in the sense of inheritance, meaning an object that could be used whenever we expect a t. So as a bonus, this mechanism gives us the Eiffel version of a mechanism that exists in just about every object-oriented language to test whether an object has a certain expected type, sometimes known as type narrowing or downcasting. It turns out that we don't need the t in our examples for this discussion, but in the general case it can be useful. So this is what the expression tells us. It tells us whether exp is attached or not, and in addition it uses the local name to refer to the value of x captured here throughout a certain part of the program known as the scope of the object test. Here are the variants of this construct. We can say attach tx as x, this is the general version. We can say attach x as x, which is what we're going to use. We could also get rid of x if we don't need it, and we could also have just x. However, the version interesting for our purposes is x as x. Note, by the way, that the last form means the same as exp not equal to void. And in fact, in our example, we could say if p not equal to void, in this case we need of course to use p rather than x, there is no x, and it's going to compile, it works, and as before it runs but without any interesting result. So how does this help us for void safety? An object test has a scope which is the part of the program where x is meaningful. There are three interesting cases. The first case is using the object test as the condition of a conditional instruction, an if then else, as here. So in that case, the scope of x is the then part, the then clause. And you can see that because we have checked that x was attached as the value of x, then we can use in this body, we can use an operation, an arbitrary operation on x, and then there's the guarantee that x is not void, so the operation will work. On the other hand, of course, if we were using it in the else clause, then x dot operation would fail, triggering a void call, a null pointer dereferencing. That's the first case. The second interesting case is the else part of such a conditional, but then of course in that case the object test should be used in a negative form, not attached of x. Then in that case we can use x dot operation for any operation in the else clause. The third interesting case is that of a loop in which the exit condition again is a negation, not attached exp, and in that case the scope is the body of the loop. You know, this loop repeats this body, and of course in the body of the loop we are sure, because the exit condition is not attached exp, we are sure that x is representing the value of x is not void, and so we can apply x dot operation. So a typical example of this is the traversal of a linked structure. Let's assume that we have first pointing to a certain list element, and then right and right and right, and at the end the list is void terminated, so the last right is void. Well, how do we loop through this? We could use more iterator mechanism. But if we want to do it directly, we initialize A to first, and then we loop until not attached A, and in that case we can do X dot operation. A receives A dot write. This is a typical loop scheme which is guaranteed to be safe because X dot operation is only executed when X is non-void. So this is what object test gives us, but of course it's a very restrictive mechanism. It's the same thing as getting rid of traffic accidents by essentially protecting everything everywhere. That is not very realistic. So our aim for the remainder of the void safe mechanism description is going to make sure that we only use object test when we need to, and we are going to start seeing some other ways of achieving this goal in the next video, part 3. So please watch for the forthcoming part 3 of the void safety in the void safety Eiffel series.